So this is our week 1, day 1 reflection video. So we finished day 1, and this is also going to serve as our day 2 preview video, because you'll notice the problem on this is a little bit different than what y'all did today. It's a little bit more complicated, and that's what you're going to see tomorrow. So we're just going to do a quick little preview of it. I'm going to start off by sketching it. I've already got my line drawn, and I'm going to do the left side. So we start off with our two x's. And remember, we do x's, our variables, as triangles. So I'm going to do 2 triangles. And then we have a 9. That's a constant. It's a number without a variable, without a letter. Those are going to be the cubes. So 2 x's plus a 9. And then on the right side, I've got 3 x's. So I'm going to make 3 triangles. And then my 8 constant, the number without the letter again, that's going to be a cube, 8 cube. And so this looks a little different than what we had today. Today, when we were doing it, we might have a problem that was 2x equals 8, and we would do the 2x's as the 2 triangles and the 8 constant as the 8 cube. But now we have x's and triangles on both sides and constants, the number cubes on both sides. So now it's a little bit different. How are we going to solve this? And I'm just going to give you a preview of how we solve it. One thing that we find out is in the guess and check method, while it's great for the really short ones, like you did today over here, it gets a little bit cumbersome for the longer ones. So instead of doing that, I'm going to show you what we call the rules for solving with the sketching method. And one of those rules is that you can do the same thing on both sides. And what you're trying to do is get the triangles, which represent the x's, by themselves. Because at the very end, you want to know what does one triangle equal so that you'll know what does x equal. So one thing that I can do is I can say, hey, I've got triangles on both sides, so I can take away triangles. And as long as I take away the same from both sides, then my equation is still what we call balanced. It's still equal because I'm doing the same thing on both sides. So if I take away one triangle from the right side, I have to take away one from the left side. And then I notice I still have triangles on both sides. So I'm going to take away another triangle from the right, and I'm going to take one from the left. And now I don't have any triangles on the left side anymore, so I can't just keep taking it away. So I'm just going to come down here and show what I've got left. I've got that one triangle here left and this 8 cube. And on the other side, I have this 9 cube left. Okay, well, just like we can take away triangles from both sides, we can take away cubes if we have them on both sides, and we definitely do. And remember, we always want to get our triangles by themselves. So I'm going to go over here to this side that's got the triangle, and notice I've got an 8 cube there. So I can take that away. But if I take away, and I'm going to do it like this, a little bit more obvious. If I take away an 8 cube from the right side, then I literally have to come over here to this left side. Let me see if it'll let me move this one over. Just move it over a little bit so I can write. And I have to take away an 8 cube from the left side so that I'm doing it on both sides. Now, when I actually figure this out, it's got 9 minus 8. Well, 9 minus 8 is a 1. I'm just going to erase this and get it out of my way. So I have a 1 cube left on this side, and now all that's left on the other side is a triangle. And I can write it in this order, or I can flip it around to make it look like that. It's the same thing. I know that a triangle is a 1. And since a triangle is my x, I now know that x is 1, and I've solved my equation.